Hi everyone. In this video, we will be talking about related rates for Math 1451 at Texas Tech University, which is Calculus 1. So what is a related rate? A related rate is exactly what it sounds like. It's some rate of change that's related to something else. So in real life, we can think about this as, for example, height and your age. So when we are young children, the rate of changes our height is faster than the rate of changes of our height, say, whenever we are 50 years old. So when you compare the rate of change of the height of a 10-year-old and a 50-year-old, we can clearly see that the rate of change of a height is directly correlated to age. So that's kind of a real life example where we can see, okay, yeah, some rates of change are related to other things. So in these examples, we are going to be looking at things that are more concrete. So we're going to look at things that often use area or volume formulas that relate lots of different variables together, right? Length, width, radius, height, things like this that are all related within an area or volume formula. So whenever we're solving related rates questions, we're going to solve these questions like a traditional word problem. And so there are going to be 6 steps that we're going to follow in this video and on this worksheet to solve these word problems. So first off, just like a normal word problem, our first step is going to be to identify our known and unknown quantities. So this is just using the words of the problem to figure out what we're doing, right? So the problem may tell us the height of something, the radius of something, and what we're looking for. So after we do this, we want to find a formula that includes all the quantities in our question. Okay, so like I said, for the questions that we often work with in Calculus 1, these are just going to be an area or a volume formula, and oftentimes the question will tell you what that's going to be. For some cases, whenever we look at problems that are set up as triangles, oftentimes one elusive formula that we use tends to be the Pythagorean theorem. So if you're having a hard time finding a formula that includes all the knowns and unknowns, I would recommend drawing a picture. And if that picture takes the form of a right triangle, then you're likely going to need to use the Pythagorean theorem. Okay, so once we find that formula, we have an extra step of differentiation here in the middle. So we're going to apply implicit differentiation. And one thing to note here is that we're always going to be applying d over dt. So all of our rates are going to change with respect to time. So that means we're going to differentiate with respect to time. So d over dt here. After we apply implicit differentiation on the formula we found in number 2, the next step is to plug in our known quantities. So anything that the question told us, we are going to plug this into our formula, and then we can solve for our unknown quantity. And the last thing we're going to do is we are going to write a conclusion. So whenever we're writing this conclusion, we want to think about, okay, what did the question say? What was the context of what was happening that gave me this formula that I now solved? And we want to remember to include any units. So depending on if this is on online homework or on a written exam, the units may be already given to you in your answer submission. So for example, if you're just submitting a number into your online homework system, this may not be as important, but if it's on a written exam or homework or quiz, it may be a little bit more important for you. And we want to think about our answer in the context of the question. So for example, if we are draining a rectangular swimming pool and we figure out that the height is changing at a rate of 2 inches per minute, well, that may not make that much sense, right? If we're draining a pool, the height of the water in the pool should be decreasing. So think about if our answer should be increasing or decreasing, because these answers can be positive or negative depending on, for example, if we're filling up a pool, then the volume and the radius are, the volume and the length and the height are increasing. However, if we are draining a pool, then that volume and height are decreasing. So these answers can be positive or negative. And whenever you're writing your conclusion, just go back and think, does this make sense in the context of the question that I was asked? So these are the steps to solve the word problems. So we're going to pause this video here, and we have a subsequent video where we're going to work through this example together.